color, which gives a distinctive feature to an object, is not a part of that object at all. That is, color is not something that an object possesses. Rather, it is quite opposite. So if a red apple does not have anything red in its surface, then how does it appear red to us? Confused? Let me explain it. Let's begin by clearing these three concepts: wavelength of light, absorption and reflection of light by a surface, and color receptors of our eyes. Light consists of energized wave-like particles called wavelengths. A ray of light has a mixture of 7 unique wavelengths that appears to the brain as colors of a rainbow: violet, indigo, blue, green, yellow, orange, and red. It should be noted that these wavelengths are actually invisible and cannot appear to us directly as colors. In a room that has a source of light, the objects in it will either absorb or reflect all or some of the wavelengths of the light. So if a surface of an object absorbs all the wavelengths it receives, the object appears black to our brain because it is not reflecting any wavelengths into our eyes. And if a surface reflects all the wavelengths it receives, the object appears white because all the wavelengths have entered into our eyes. But when an object appears to have color, like red, its surface is actually reflecting only the red wavelength while absorbing the remaining 6 wavelengths. There are 3 color receptors in a human eye: red cone, blue cone, and green cone. If a particular wavelength, say red, enters an eye, it activates the red cone and we see red color. If these cones were not present in our eyes, our brain would tell us that the world is just black and white. But how can only just a 3 color receptors help us see more than 3 colors? It's simply because the wavelengths received by the 3 cones can combine in pairs to reproduce a wide range of colors. So an apple is not truly red, it just appears as red to our brain. Here is how it happens. When the light hits the surface of an apple, the surface absorbs all the wavelengths except for the red wavelength. The red wavelength gets reflected and is received by the eyes. In the eyes, the red wavelength activates the red receptors. Thereafter, the red cone sends signals to the brain, which is then interpreted by the brain as red color. And this is how we perceive color, which is totally dependent on light, the object reflecting the light, and our eyes. Therefore, we can say that things don't actually possess colors, but rather they reflect light that activates the colors in our eyes.